All right, we are going to keep going with our work in our unit on basic and compound probability. And specifically in this video, we'll be looking at Venn diagrams, and I'll show you an introduction, and then we'll do an example. Okay, so Venn diagrams are a great visual way of just showing what objects fall into what categories or groups. And just up here for the introduction, I'll just show you the classic example of an overlapping Venn diagram, and they might represent two different categories. And so in this example, you know, the classic Venn diagram in geometry is using quadrilaterals, and so this might represent rectangles. So all quadrilaterals that have 90-degree angles, and this might represent the category of a rhombus, all quadrilaterals that have equal sides. And then the overlap represents a square, those quadrilaterals that have both traits, both attributes. Okay. The thing that we need to remember, and is sometimes hard to draw out carefully, is that in this case, the rectangles category refers to the entire oval. It doesn't just refer to what I'm shading in yellow right now. It refers to the entire oval shaded in yellow. Okay, so just kind of keep that in mind, and sometimes you want to be careful about how you label things. Okay, and then the rhombus refers to this entire oval in red. And so what is both shaded in red and yellow? It's the square, right? So that's the both category. So let's look at a quick real-world example, and it's around a survey of college students. So the scenario is this. I found some data from a survey of college students at CU, and I learned that 56% of all students live in the dorms, 62% are on the meal plan, and 42% do both, live in the dorms and are on the meal plan. Okay, so let's try to color coordinate a little bit here, and I'll have living in the dorms be red, and let's have blue be on the meal plan. Okay. And so let's draw a couple overlapping circles. So first in red, so this is our dorms category. And then next in blue, this is our meal plan category. Okay. And so we actually have 4 groups of people here, because I am going to draw what we can think of as the sample space, the entire group of people that was surveyed. And this is all the people together. Okay, so we have 4 categories here. We have people that live in the dorms and are on the meal plan, people that live in the dorms but are not on the meal plan, people that don't live in the dorms and are on the meal plan, and people that are not living in the dorms, so they're living off campus, and they're also not on the meal plan. Okay? So we have 4 categories of people to think about, and hopefully from the information we're given, we can fill in some numbers. One thing to keep in mind is the size of these zones that I've drawn it's not to scale. It doesn't represent sort of the size of the group in that zone. Okay, so don't think that these are a scale diagram. So what I always like to do for these is to think about the both first. Okay, so this is my both right here. 42% are in both. Okay, and by the way, I hope you're realizing that all the entire box needs to be 100%. Okay, so that's all the people we surveyed. 56% of students live in the dorm. So here's a common mistake. People write that, 56% right there. Okay, but that's not going to be true because we want to have those 42% be part of the 56%. Okay. So, and actually let me try to color coordinate a little bit better here. So both, I think, should be purple, because that's red and blue. So that's a 42 right there. Okay. And then the red, just the dorms, should be 14. Okay. Because we want these these two numbers to add up to 56, okay? The total number of people that live in the dorms, and they do, okay? And then lastly, it says 62% are on the meal plan. That means 20 are only on the meal plan without living in a dorm. Okay, so we can add up now these three numbers, and we need to figure out the people who are in neither category. Okay, and we're going to do that by adding up the three numbers and subtracting from 100. So this is a 24 right here. And I'm not writing the percent symbol just to keep my diagram a little bit cleaner, but those are all percents right there. We didn't survey exactly 100 people. All right, a way to check that, which I'm not going to do, but a way you could do is just to add up all those four numbers and double check to make sure they add up to 100. And then we have some questions to answer over on the right side. So what's the probability that someone lives in the dorm and is on the meal plan? Well, we were given that number. That's a 42%. Okay. What's the probability that someone is not on the meal plan? Remember that bar means not, it refers to the complement. Okay. What's the probability that someone's not on the meal plan? Well, we want to include these 24 people and these 14 people. So those are all the people that aren't inside the blue oval. Okay, so that would be 24 and 14 is 38%. What's the probability that someone is either in the dorm or on the meal plan? Okay, so a couple ways of thinking about this. We could use the formula, dorm plus meal plan minus both. And so that would be 56 plus 62 minus those 42 people, or 42% that we double counted. And that equals 76%. The other thing you could do is just add up these three separate numbers, okay? And that would equal 76% as well. So you can just go straight from the Venn diagram. Okay. And lastly, what's the chance that someone is not either in the dorm or on the meal plan? So look at these two questions right here. One's the complement of the other. So they have to add up to a whole, they have to add up to 100%. So easiest is to just call this 24%, but we could have seen that just from the Venn diagram as well. All right, and next question I want to look at, and this will be our last, our last question for this video, is to check for independence mathematically. Okay, so first off, you can think in your mind, is there a relationship between living in a dorm and being on the meal plan? If you pick somebody and you know they live in the dorm, does that make them more or less likely to be on the meal plan? There probably is, right? If you're living in the dorm, you're probably on the college meal plan. If you're living off campus, there's a pretty good chance you're not on the meal plan. So they're probably not independent, but we can check mathematically as well. So remember, if things are independent, then the probability of A and B is the probability of A times the probability of B. So if things are independent, then this statement is true. Okay, let me give myself a little more space here. Okay, so let me try to visualize this for you a little bit. If things are independent, then that statement is true. But what we also know, or I'm explaining right now, is if that statement is true, then things are independent. So that's a bidirectional conditional statement. We call that in logic or geometry. But we can kind of go both ways with that if-then statement. So we can show that a couple things are independent if we can show that the and statement, if we can show that this formula works out. So let's go do it. So going up from above, what's the probability of both? 0.42. And we're checking, is that equal to probability of dorms is 56.56 times the probability of a meal plan 0.62. So we're wondering, are those two, is that equation valid? Okay, so is 0.42 equal to 0.35? And it's not, it's pretty far off, okay? So that means they are not, those two events are not independent. That means there's some sort of a relationship between living in the dorms and whether or not you're on the meal plan. It doesn't tell us what that relationship is, it just tells us there's some sort of a connection in there. Once you get into more advanced statistics and statistical analysis, you'll be able to look at something like this and analyze it much more precisely and formally. But right now we're just saying, hey, these two numbers are not the same, so they're not independent. All right, that's a good place to leave it right there.